So yesterday in class we talked about rate of change, average rate of change, and I was trying to tell you that every graph has a rate of change. Okay, but we have a special word for the rate of change in a line graph or a linear graph. We call that slope. So what I'd like to do here is these are some notes, and I'm going to fill some of it in for you and guide you through how to fill it in. And I'd like you to fill in the rest on your own. And I'll be collecting on Monday for a grade, okay? Just make sure you leave it in your folder, and I'll have it over the weekend to take a look at, okay? So reading this, if you want to read it out loud, so you're going to estimate a rate of change from a graph, and you'll calculate and interpret the average rate of change of a function, and over specific intervals you'll find the average rate of change, okay? A rate of change is quantities expressed as ratio, so miles per gallons of gas, cost per kilowatt of power, miles per hour. Rate of change tells us how much one quantity is changing with respect to another quantity. For example, the speed of 60 miles per hour tells us that a vehicle travels 60 miles for each hour it is driven. Average rate of change, some rates of change are constant and others are not. For example, if a car travels from one city to another, it does not normally travel at a constant rate. The car will speed up, slow down, depending on traffic, and may stop for a period of time, so the driver and passengers can grab a bite to eat. When the rate is not constant, we often look at the average rate of change. The average rate of change can tell us how much one quantity changes with respect to another quantity. So average rate of change is basically if the graph is not straight, we estimate it so it is straight. Okay. So this example down here. All right. A distance marathoner runs over time is represented in this graph. So this y-axis here is going to be our distance, and this x-axis here will be our time. Just kind of like what we did with Usain Bolt. All right. What is the average rate of change in distance over the entire 6 hours of the race? So we find the average rate of change, okay, or in this case we want this. Well, the whole graph isn't straight, so it's not really slope. But you find the average rate of change simply like so. Remember, you start at the starting point and you look at your ending point. And if you want to use your slope formula, here's how it works. We're going to take, first you're going to do the change in y, the y-axis, so that's the distance, over your change in x, which is your x-axis. Well, your y values are going to be, well, you got 0, 0 for one of them, and your other y value is going to be, let's see, 626. So what does that mean? Well, 26 will go first. That's the y value here. And then down here, your point is 0, 0. So 0 will go next for the y. So x, it would be 6, 6 for x, and 0 for x down here. When you subtract those two, you get 26, what is that, miles per 6 hours. And we can simplify that fraction. And if we simplify that fraction, like dividing both by 2, you get 13 miles per 3 hours. And that would be your average rate of change. The average rate of change in distance between the first and second hour. So this is the first hour, this is the second hour. So we're going from this point to this point. And this point is 1, 6, and this point up here is going to be 2, 8. Okay, so just reading the points on the graph. And we'll find the average rate of change here. So we're going to find the difference in the y's first. So the y values is 8 and 6. So 8 here. 6 here, and the x value is going to be 2 and 1, so 2 and 1. And when you do that difference, 8 minus 6 is 2, 2 minus 1 is 1. That means our rate of change is going to be 2 miles, because that's our distance here. Up here is miles per 1 hour, so 2 miles per hour. All right. Between the 6th and the 4th, we need to find the average rate of change between the 4th and the 6th. So here's 4, here's 6. So my point right here is going to be 4, and that goes over 16. 416. Try to make that more like a 16. 416. So because I'm running out of room, I'm going to grab a sticky note. Make sure that's there. Here you go. 4th hour. There we go. So we're going to do the change in y over the change in x. Alright, so a change in y. So our y value here is 16. And for the 4th hour, oh, that's 16. 6th hour, I want 26. So 26 and 16. Alright, and then the x value is going to be 6 and 4. So 6 and 4. Okay. And we're going to subtract those. So this is going to be 10 over 2. So 10 miles for 2 hours. Can't forget what we're talking about. The context of this is marathons run a race. So how far is he going in what time? So he is going about 5 miles to 1 hour, which is actually quite decent. Average person hiking speed is about 20 minutes a mile. So that's about 3 miles per hour. He's going 5 miles per hour. He's doing all right. Okay, so D, is the rate of change in distance constant over the entire 6 hours? And explain. It is not constant over 6 hours, because if you look at these lines here, this rate of change here is different than the rate of change here. The rate of change here is different from the rate of change here. The rate of change here is different from the rate of change here. So we're not constantly going 6 miles an hour the whole time. We're changing. We start out fast, we get slower, we stop for a little bit, then we go a little further and get faster. What's happening between 2 and 3 hours? Well, 2 hours, it looks like he took a break because he's not going any distance, and he's stopped for between 2 to 3 hours, or between hour 2 and 3. Okay. All right, so let's look at this next problem. I'm actually going to stop for a moment, give you a break, and then work out this next problem. Okay. Hey, what's up?